Hey guys, Mr. Jenkins back here with our second lesson from chapter 5. Yesterday we did 5.1, which was about slope and rate of change. If you can see there, we're doing 5.3 today, so that means we're skipping 5.2, just getting to the most important stuff. And this is one of those lessons that is very important. We're talking about slope-intercept form today. So we talked a lot about this in pre-algebra. Hopefully that proves to be helpful as we're working through this. I think I'm going to split this lesson into 2 days, so just because there's a lot to it. Our learning targets, we want to be able to write linear equations using slope-intercept form, and then we want to be able to graph linear equations that are written in slope-intercept form. Slope-intercept form, if you do not remember, is y equals mx plus b. So a couple things. Y is by itself. It's written as the output variable. Y is a function of x. And then m is known as our slope. Let's see. No, it's not one of our vocab words. That's our slope. And our b is our y-intercept, also known as our initial value. All right, here goes. Looking at example 1, it says find the slope and the y-intercept of the graph in each equation. So what we have to do first here is make sure that it does say y equals. All right, so on this, you must solve for y if necessary. In other words, actually looking at these, none of these say y equals. So none of them are already written in slope-intercept form. All right, so what do we need to do to make that happen in example A? That just says 2 times y, so we need to undo that. So I am dividing everything by 2. On this side, that would give me y. On the other side, 4x over 2 would be 2x. And minus 2 over 2 would be minus 1. Okay, now I can look at this and tell that the slope, or m, is 2. And the y-intercept, or b, is -1. Now instead of, I think MathXL would take -1. I kind of would like for you to think of that as an ordered pair. So that's the point 0, comma, -1. I will look at, I'm going to leave b for you guys. Let's look at c. So on c, we need to divide both sides by 3. And that's going to give me y equals -6x over 3. And that would simplify to -2x. So on this one, the slope of the line would be -2. And then what about b? So we could write +0, and that would be equal to the same thing. So b equals 0, or it goes through the point 0, comma, 0. Okay. That's a special kind of line right there. That's one we refer to as a proportional line. It's a proportional relationship. Make that look more like an equal sign. Then on the last one, again, what do we need to do to have y by itself? We need to move +6 over there, or get rid of +6. You can think of that either way. When we subtract 6 from both sides, we get y equals 0 minus 6. And that would be -6. So in this case, what's the slope? Well, we don't see an x term, right? So that could also be written as y equals 0x minus 6, right? So the slope is 0. And the y-intercept is b equals 0, comma, -6. So my follow-up question to you here would be, what kind of line is this, right? There's a special kind of line that has a slope of 0. So take a second and try to answer that. All right, moving on to example 2. Example 2 gives us m and gives us b and wants us to write it into slope-intercept form. So this is a really simple example. So we would go y equals, and remember it's m times x. So 1 times x plus whatever b is. So in this case, -1. Then we would just want to clean that up. 1 times x is just x, so y equals x. And then plus -1, we would rather see that written as -1. All right, I'll leave the next two for you. Nothing too fancy on that example. I want to look at example 3 and then maybe one more. Okay. All right, looking at A. Well, looking at any of these, if I give you a graph and tell me to write a slope-intercept form equation, you should probably follow these steps. So step 1 would be we wanna figure out the easiest thing first. So B equals what? All right. And then step 2 is M equals what? And then step 3 is we sub everything in. Okay. All right. So on this one, example A, step 1, what is B? Where does it cross the y-axis? It goes through the point 0, 3. So we could say B equals 3 or 0, 3. All right, and then step 2, what's the slope? So we know it goes through this point. There's another corner point, it looks like, goes through 2, 2. Just make sure we can follow that same pattern, down 1, right 2. So all looks good there. Okay, or up 1, left 2. All right, anyways, remember to get the slope. I'm going to look from here to here. All right, so my rise to get from this one to that one. Also, remember, you can look early. Hopefully, you can see that's a negative slope line. Okay. Anyways, our rise is down 1, so that'd be -1. And our run is +2 because we went to the right 2. So M equals -1 over +2. That would be -1/2. So then 3, as we kind of finalize our answer, y equals -1/2 times x plus 3. It's kind of neat what you do when you're doing this. We don't always think about it, but we just wrote the rule that assigns each of these inputs to its corresponding output. Okay, so this is the rule where if I plug 2 in, then I should get 2 out. If I plug -2 in, then I should get a 4 out, right? So it's kind of a neat thing that we do there. Let's do one more of these. All right, looking at B. Step 1, we want to figure out B equals what? Looks like this one crosses through the point 0, 0. So B equals 0. And then M. We got lots of what I like to call corner points that we can choose from to figure out what M equals. All right, so just to show you that maybe also since these are kind of close together, let's figure out what the slope is from here, and let's skip a couple and go to there. Okay, so the slope to get from here to there, really you would want to just look from here to there, but just to make this a little bit easier to see, I'm going to go from here to here. So my rise would be up, looks like up 3, up is plus. And then my run is right 3, so over 3. So step 2 would be that M is 3 over 3, which is equal to 1. Okay, if we found from here to here, we would just do up 1 over 1. 1 over 1 is also 1. And then we finalize. Y equals M times X. So 1 times X is just X plus 0. Let me actually write that out. So we can talk about simplifying. So Y equals 1 times X plus 0. So really we just simplify that to Y equals 1 times X is X plus 0. We don't need to write, so Y is equal to X. This rule is easy to check, right? So is this the rule that, if I sub in 2, does that take me to 2? Yeah. If I sub in -2, should that take me to -2? Yeah, that makes sense within the context of this rule. All right, there's a couple more for you guys to maybe try. I know you probably can't see it great on your screen, but I suggest you pull up the blank notes or the filled out notes to be able to better see the lines, and then you should try those, okay? So we will finish up, and I'll do example 4 tomorrow. So here's what I won't do tomorrow when we're doing questions. You're going to ask me, Mr. Jenkins, how do I do these? They only gave me 2 points and no graph. Tell me to write the equation. The answer is going to be you have to wait until tomorrow's video. Okay, so I'll finish example 4 and example 6 tomorrow. We're focusing on the basics today. All right, so let's graph a couple. A is about as simple as it gets. It's given to us in slope-intercept form, and we just have to graph it. All right, so our steps here are similar. I would always start from our B. So B is 0, -1. Or you could say B is -1. So the problem with B is -1 is a lot of people will start here. So that is not it. Our y-intercept is -1. That's why I like to write it as an ordered pair. And then from there, m equals what? M equals 2. If I'm graphing, I like to think of that as a fraction. Any whole number can be written over 1. So 2 over 1. So that means I can rise 2, run 1. Rise 2 takes me there, run 1 takes me there. So it also goes through 1, 1. I can also do this. I can do the opposite of both. So I can do -2 over -1, which would be down 2 and left 1. See, that's still on the same line. Okay. All of these are going to be continuous functions. In other words, we're not really looking at discrete versus continuous much anymore. So you always finish by drawing your line, use a straight edge. That school ID works nice. And then finish with arrowheads on both sides. That just shows that the line continues on forever. All right, looking at B, example B, not the y-intercept. Well, we will look at the y-intercept. But first, we have to solve for y. So we want to move -4 over there. It'd be +4 on the other side. So you got y equals -1/3 x plus 4. Don't forget that. If it's -4 over here, it's +4 over there. Because we add 4 to, quote, get rid of it. Now we can identify that B is 4. So that's a good reminder. If we don't do that, we might think B is -4. B is actually +4. Let's do 0, 4. And then my slope is -1/3. Just look at my coefficient of x to figure that out. So -1/3, that could mean -1 over +3 or +1 over -3. Both of those mean the same thing. All right, so -1 over +3, that would mean rise -1 would be down 1, run +3 would be run 1, 2, 3 to the right. This one would be rise +1, so up 1, and then run -3, so left 1, 2, 3. All right, so finish with your straight edge. Like I said, that school ID works nice to make a nice, neat line. You don't even really have to do much of that because you can use Math Excel and all that fancy stuff. I extended my line a little bit. You just want to go to the points, that's fine. That way you don't get off track somewhere. Let's see, is there anything else? Let's maybe do, I'm going to leave C for you. Let's maybe do D, and then that'll finish us out. We'll do example 6 on day 2's lesson. All right, so go ahead and we want to move plus half x over first. So that's going to give me 2y equals negative 1/2 x minus 8 was already over there. Now we want to divide everything by 2. So I would go ahead and try to type that in. What is negative 1/2 divided by 2? Negative 1/2 divided by 2. That would be either negative 0.25 or negative 1/4. So negative 1/4 x minus 8 over 2 would be minus 4. Now we're ready to graph it. So we're going to say b equals 0, negative 4. And m equals negative 1/4. Okay, so negative 1/4 can be negative 1, down 1, and then over positive 4. So 1, 2, 3, 4. Or it could be positive 1 over negative 4. So up 1 and left 1, 2, 3, 4. Always look at the end. Does that look like a negative slope line? And yes, that would be a decreasing function. So looks good to me. It passes the eye test, in other words. All right, so use my straight edge, and then don't forget to draw those arrowheads, signify that the line goes on forever. All right, so that would be it on this one. Hopefully this is more review than new stuff, but hopefully it helps because we always go just a little bit deeper in Algebra 1 than in pre-algebra. So make sure you're staying up on things. And remember, this is a 2-day lesson. So if you get to something on the homework you can't do, then you're going to be like a lot of people. We'll spend a couple days on this. Thanks, and have a good one.